So good morning. Today we will discuss some questions from vectors, mostly related to the addition of vectors with diagrams. That's the area where I find that children have some doubts. So let me share my screen with you for some questions and we will solve the questions on the whiteboard. Can you see the screen now? Can you see the screen?
Yes, teacher.
Okay, so the first question is, a body is pulled towards east with 50 Newton force and then it is pulled towards north with 20 Newton force, making an angle 60 degree with the east. Find the magnitude and direction of the resultant force. So this is the question. You read the question yourself, try to understand it. By that time, I will try to draw the figure for this question. A body is pulled towards east with 50 Newton force, right? So towards east, a body is pulled with 50 Newton force and then it is pulled towards north with 20 Newton force. So towards east, there should be 50 Newton force and towards north, 20 Newton force, making an angle 60 degree with the east. So it's not exactly towards north, it's making an angle 60 degree towards the north and the force is 20 Newton. Find the magnitude and direction of the resultant force. That's the question. So I'm stopping the share. So we have seen in the question that the force of 50 Newton is applied towards the east and another force of 20 Newton is applied, making an angle 60 degree from the east. So it's not exactly along north, it's just making an angle 60 degree from the east towards north. So this is the diagram. And we have to find the resultant force. So how will you find the resultant force? R is equal to, we have learned formula to find the magnitude and direction of the resultant force. Do you remember the formula to find the resultant force? R is equal to root over P square plus Q square plus 2PQ cos alpha, where alpha is the angle between the two vectors. Here let me consider P as equal to 50 Newton and Q as equal to 20 Newton and the angle between them is taken as alpha. So I have all the things to find the magnitude of the resultant force. So that's equal to root over 50 square plus 20 square plus 2 times 50 times 20 times cos 60. You can use your calculator to find this out. I'll just check the answer directly to not to waste time. So you can do this with the calculator. And the result is 3900. 3900 Newton. So we got the magnitude of the resultant force. Oh, no, root of this quantity, which will be, I was wondering how this much. This is equal to 62.45 Newton. So this much is the force, this is the magnitude, and to find the direction, which equation can we use? To find the direction, tan theta, where theta will be the angle made by the resultant with one of the forces, say 15 Newton force. Tan theta is equal to Q sine alpha divided by, don't you remember the formula? What is it? P plus Q cos alpha. So this is equal to, what is Q? Q is the second one. So 20 divided by 50 plus 20 cos 60. Okay, sine 60. Okay. So you will get the answer for tan theta is equal to 0.2886 if you use the calculator. If you use the calculator, this is the value you get. And then theta can be found out as tan inverse of 0.2886. What is that? Please use your calculator and find out. It is 16.1 degree or just 16 degree. So you can tell that the resultant force will be 62.45 Newton towards north, making an angle of 16 degree from the east. So that is how you have to tell the answer, that the resultant force is 62.45 Newton towards north, making an angle of 16 degree from the east. Is it clear? Is this clear to you? How to solve? This is a
Yes,
simple
teacher.
problem. Okay. So that's how we can solve a simple problem for addition of vectors. Let us go to the next problem. Okay. If there is no current, a swimmer can swim with a velocity of 4 km per hour. In which direction the swimmer has to swim if he has to go from one side of a river to another side and exactly to the opposite point? Given that the river is flowing straight with velocity 2 km per hour. In such questions, you have to draw a diagram according to the given situation. So looking at the problem, you yourself can try to draw a diagram that represents this question. If there is no current, a swimmer can swim with a velocity of 4 km per hour. In which direction the swimmer has to swim if he has to go from one side of the river to the other side and exactly to the opposite point. So you have to draw a river from one point exactly opposite another point should be there, and then given that the river is flowing with 2 km per hour, so the speed of the river is 2 km per hour. Okay, and the person can swim with a speed of 4 km per hour. So 4 km per hour. And the question is, in which direction the swimmer have to swim if he has to go from one side of the river to another side and exactly the opposite point. So I have shown what they told in the question, that suppose this is a river and which is flowing with the speed of 2 km per hour. So in order to reach here, if the person directly swim from A, will he reach B? No, because the river is flowing in this direction. So if he swim directly towards B, he will end up somewhere here. So in order to reach here, he has to swim in this direction. So the resultant should be this. So you have two velocities. One is in this direction. It's in this direction. The resultant should be this. So this should be the resultant. The angle made by the resultant with one of the vectors should be 90 degree. We have to find what should be the angle between these two vectors. So for the formula, we usually use the symbol P and Q. P for the first vector and Q for the second vector, right? So we can use this idea P, Q And what should be the angle between them? The resultant angle is 90 degree. So we know that tan theta, the resultant angle, is equal to Q sine alpha. Alpha is the angle between these two vectors, which we have to find out, divided by P plus Q cos alpha. The resultant angle theta should be equal to 90 degree. And they have given P. P is equal to 2 kilometer per hour. And Q is equal to 4 kilometer per hour. What is alpha? This is the question. Okay. So for that, let us put all the quantities in this equation. So we get tan 90 degree is equal to 4 sine alpha divided by 2 plus 4 cos alpha. Now what is tan 90? What is tan?
Undefined. Undefined.
It's undefined. Tan 90 is undefined. Why? Tan 90 means sine 90 by cos 90, right? Sine 90 is equal to 1, cos 90 is equal to 0. 1 by 0 is undefined. So anything divided by 0 is undefined, right? So undefined quantity is 4 sine alpha divided by 2 plus 4 cos alpha. So we can say that a quantity will be undefined if its denominator is 0. So we can directly put this value as equal to 0. So we can put this implies that 2 plus 4 cos alpha is equal to 0, or 4 cos alpha is equal to minus 2. When I take plus 2 to other side, minus 2, or cos alpha is equal to minus 2 by 4, which is equal to minus 1 by 2. So what is alpha? You can find cos inverse of minus 1 by 2 using your calculator. So try to find cos inverse of minus 1 by 2. Cos inverse of minus 1 by 2, what is that? That is equal to 120 degree. So this is how you have to solve equations when a word problem is given in vectors. First, try to draw a diagram that represents the word problem, and once you get the diagram, you can solve it. Is this clear to you? Is this problem clear to you?
Yes, teacher.
Okay. So let me go to the next one. So let us see the next question. Okay, a wind is blowing with velocity of 20 kilometer per hour towards the south, making an angle 60 degree with the west. So it's southwest. It should be between south and west. What are the magnitudes of the component of wind velocity to north and east? So towards the north, there will be one component. Towards the east, there will be another component. So we have to find that. So try to draw by yourself a diagram showing the situation given in this. Yes? Someone was asking something? Okay. So let me try to draw that. You try to draw yourself. You have east, west, north, and south should be there. First, you have to draw something having a velocity of 20 kilometer per hour towards the south, making an angle 60 degree with the west. So I'm drawing something with 60 degree, 20 kilometer per hour. Now the same thing you have to resolve in the northeast direction. So this is related to resolution of vectors. So let me stop share and you can see the whiteboard now. I have tried to draw the same diagram. They told that wind is blowing in the southwest direction 20 kilometer per hour, making an angle 60 degree with the west. So between west and the wind, I have made the wind is towards the south, making 60 degree. So this is one line. When I try to take it in the northeast direction, this is one line, right? So this angle and this angle will be equal because they are alternate interior angles. So these are equal angles. So this angle will be 60. Now we find the component of the wind along the east direction and component of wind along the north direction. Now look here, here you have a resultant vector which we have to resolve in the x direction and y direction. Remember, when we are resolving a vector in two perpendicular directions, along the x direction or along the horizontal, if this angle is 60 degree, what will be the component along this side? What will be the component along east? Along the side where 60 degrees touching.
30.
How did you get it?
90 minus 60.
I'm not asking about this angle. I'm asking what will be the component. Suppose you have a vector A which is resolved into the x direction and y direction. The angle is theta. So how will you take the component along
Cos theta. A cos theta.
A cos theta, and what will be this one?
A sin theta.
A sin theta. So here you know that this is equal to 20 kilometer per hour, right? And this angle is 60. So what will be this value? 20 into cos 60. Got it? The magnitude is 20 kilometer per hour. The velocity is 20 kilometer per hour. They have asked what will be the component of the wind velocity in the east direction and north direction. That's like x-axis and y-axis, making 90 degree between them. So towards the east, the component will be 20 times cos 60. And towards the north, what will be the component?
20 times sin 60.
20 times sine 60. So that is how we can resolve this wind velocity in the two directions. So you can tell that the component towards east is equal to 20 times cos 60. What is that? Cos 60 is
10.
1 by 2, right?
Yeah. 20 into half.
20 into half, 20 by 2, which is 10 kilometer per hour. So what will be this one component towards north is equal to, component towards north is equal to 20 times sine 60. Sine 60 is root
Root
3
3 by 2.
So 20 times root 3 by 2. What is that?
10 root 3.
10 root 3 kilometer per hour. See, it's not 10 and 10. It's not exactly 10 and 10, right? So it's 10 root 3 and 10 kilometer per hour. Is that clear? How to solve such a problem? Is this clear to you?
Yes, teacher.
Yeah, teacher.
Okay, so let's see. We have one more period today, so we will see a few more questions related to such addition of vectors, because I often find that children it is easy when the vectors are given in the component form, addition, multiplication, etc. But when it comes to addition with diagrams, there is often confusion.